All right, we're going to do some practice for zero and negative exponents practice problems. All right, we're going to start with zero exponent here. And remember the rule. Any number to the zero power equals 1. So since we have 5 to the zero power, this equals 1. Any number to the zero power equals 1. Number 2, same idea. Any number to the zero power equals 1. So b to the zero power equals 1. Seems kind of easy. Here we have an expression where we need to simplify two different zero exponents, but remember, any number to the zero power equals 1. So 5 to the 0 equals 1, and b to the 0 equals 1. When we add 1 plus 1, we get 2. All right, on number 4, in my book here, there's a typo. So if you're looking at your book and it looks a little different from mine, maybe you have an updated book. There should be a zero exponent here on the outside of these parentheses because this expression doesn't simplify. So putting the zero exponent on here kind of follows with our rules. Any number to the zero exponent equals 1. So this whole expression to the zero power is equal to 1. Negative 2 to the zero power equals 1. Notice it's not negative 1. So if we can take a minute here just to clarify, negative 2 to the zero power equals 1 because any base to the zero power equals 1. However, when you leave off the parentheses, you have to recall that this exponent now is only on this 2 because that's what it's right next to. It doesn't include the negative. Up here, when the negative is held in with the parentheses, the 0's on this whole base, the negative 2, so the whole thing makes negative 1. But here, the 0 is only affecting the 2. So this part of the expression will equal 1, but this negative sign is still there. So this makes negative 1. You really need to be familiar with these two expressions and the difference between them when the negative is in the parentheses and outside the parentheses. Okay, on number 6, we have 4 different bases in here that are going to get the exponent of 2, and we have this base that has a 0 power on it. So we're going to first start by putting the 2, the exponent 2, on all of these bases. So we have 5 getting a square on it, an a squared getting a square, a b0 getting a square, and a c cubed getting a square. And that's how we're going to start. Okay, 5 squared is 5 times 5, which makes 25. The rule here, when the exponents are stacked up on one base, is that you multiply them. So 2 times 2 makes 4. So this will be a to the 4th power. And we're going to do the same thing with these exponents, except this time 0 times 2 is going to give us 0. So we still have b to the 0. Same rule here when the exponents are stacked up. So this will give us 3 times 2 is going to give us an exponent of 6. And we're almost done. The only thing that's giving us an issue here is this b0 power is still stuck here in the middle. This means 1. So we can simplify that to 1. And when we do that, the 1 now becomes a coefficient, which moves to the front times the 25. So we really have a 1 times a 25 times an a to the 4th times a c to the 6th. And of course, 1 times 25 is still 25. So 25a to the 4th, c to the 6th is our final simplified answer. On number 7, we have some more 0 powers to simplify here. So we're going to start putting this exponent 4 on these 3 bases inside here. So 2 to the 4th power, x to the 0 to the 4th, y to the 5th to the 4th. And then we can look at this expression, this part of the expression down here. This 0 power on the outside of this parentheses is applying to everything in here. So all of this whole entire parentheses is going to turn into 1 because all of this is being raised to the 0 power. So we can simplify a little bit more. 2 to the 4th power is 2 times 2 times 2 times 2, which makes 16. This 1 is a coefficient now, so we're going to bring it to the front. Okay, the rule here when the exponents are stacked up is that they multiply. So 0 times 4 makes 0, so this is x to the 0 power. And here, multiply those exponents when they get stacked up like that, and we end up with y to the 20. Well, we're almost done here. We have 16 times a 1, and x to the 0 power makes another 1. And 16 times 1 is still 16. So we have 16 y to the 20. When you get really good at this, you'll be able to do a lot of this multiplication mentally, and you don't have to write everything out. But I write everything out so you guys can see exactly where everything is coming from. And it's beneficial when you're learning to write everything out. All right, on number 8, we have 6 squared over 6 cubed. We can treat these as factors, 6 times 6, 6 times 6 times 6. When we reduce them off, we just have this 1/6 left, but it's in the denominator. So in the numerator, we have a 1. You could also do this by using the subtraction rule. These are the same base, so you can do subtract the exponents, top to bottom. That gives you 6 to the negative 1 because 2 minus 3 gives you negative 1. But for this course, we always practice making our exponents positive. So you'll have to go the extra step if you do it this way to put that 6 down in the denominator to give it a positive 1 exponent. Either way, you get 1/6. I personally like this method. It seems to get you to a direct answer a little bit quicker. This has its uses sometimes, but this seems to get you there quicker without having to deal with the negative exponents. But it's up to you, whichever you're most comfortable with, you can use either way. All right, here we have 7x's over 10x's. When we reduce them off, you're going to see there are 3 x's, and they're in the denominator of the fraction. So we have x cubed in the denominator with a 1 in the numerator. Now, I could have done this without writing all of this by looking at this. Okay, 7 on the top with 10 on the bottom. That means there are 3 left over. It's still a subtraction, but if you just put those 3 wherever you had more with to start with, the 3 is positive there. Because there's more on the bottom, that's where the exponent is going to be positive. All right, on the next page, we got some more negative exponents going on here. 3 negative squared. A negative exponent means to put the base in its reciprocal. So the reciprocal of 3 is 1/3. And when you do that, the exponent becomes positive. And it doesn't matter if you write it there or if you write it here. With the 1 on the numerator, it doesn't matter. It turns out to be the same thing. It turns out to be 1/9 either way. X to the negative 5th. Again, the negative exponent means the base needs to be put in its reciprocal. The reciprocal of x is 1/x, and this will become 1/x to the 5th. All right, with these negative exponents being in the denominator, it still means the reciprocal, but the reciprocal moves that base from the denominator up to the numerator. So that's going to mean that we're going to get a 5 squared in the top of the fraction in the numerator and an a cubed in the numerator of the fraction, and the denominator will just be 1. Well, you don't really need a 1 in the denominator of any fraction because it's not really giving you any value there. So we're just going to get rid of that 1 in the denominator and simplify this. 5 squared is 25, a cubed. All right, we got some more negative exponents going on here. All right, when you have a whole bunch of bases in one fraction like this with negative and positive exponents, all you need to do is to make the exponents positive, move them from the numerator down to the denominator or from the denominator back up to the numerator. When you do that, the sign on the exponent changes. So if we have an a to the negative 4 up here in the numerator, when we move it down to the denominator, the exponent goes positive. Same thing with this b. If we move it down to the denominator, the exponent will go positive. And the c, to make the exponent go positive, can move up to the numerator of the fraction. By moving a base between the numerator and the denominator, it changes the sign on the exponent. So here we have a whole bunch more bases. I'm going to put my fraction bar there. And I'm just going to go across the top and look at all of these bases, and then across it. It looks like there's 3 bases on the top and there's 4 on the bottom. All right, so we'll start with this x. Since it has a negative exponent, we'll move it down to the bottom, and that will change the sign on the exponent. But the y already has a positive exponent, so we will keep the y where it is. We don't need to change the sign on that y. The z has a negative exponent, so we'll move it down to the bottom, and the exponent will become positive. And that took care of the whole numerator of that fraction. Now we'll go across the denominator. This negative 2, be careful, because this negative right here is not an exponent. So moving it to the top is not going to change that sign. It only happens with exponents. This negative just means below 0. The exponent on this 2 is a 1. So it already has a positive exponent. You don't need to move it top to bottom. It needs to stay where it is. So I'm going to write it here in the denominator of this fraction. It needs to be there. So I'll put it there at the beginning. This a already has a positive exponent, so it's not going to change. This b has a negative exponent, so we'll move it up to the top. The exponent becomes positive. And this d already has a positive 1 exponent, so we don't need to move it. It needs to stay. And now I'm just going to rewrite these in alphabetical order. Across the top, the b comes before y alphabetically. So b cubed, y7. Down on the denominator, the coefficient's negative 2. Then we have an a to the 6, a d, an x cubed, and a z. And these are all the same bases that you see here. I just rearranged them alphabetically. You don't have to do that. I like doing it. It just looks nicer to me. But it's not required to do. What is required is that your coefficient is in front of your variables. That is required. So make sure that you have the coefficient here in the front. It shouldn't be in the middle. And then you can have these variables in any order you want. I just think it looks nicer to put them alphabetically. All right, let's look at number 15. We've got some bases here. Ooh, this one has a negative exponent on it. And then we've got some bases over here, and this one has a negative exponent. So if we just look at this parentheses first, the 3 and the x have positive exponents. Right now, this is a fraction, isn't it? Actually, we could put this whole fraction bar over this whole thing. And that opens up the denominator for us so that we can see when we move these, we have a place to move them to make the exponent positive. So that's what we're going to do. The 3 doesn't need to move. The x to the 5th doesn't need to move because it already has a positive exponent. But this y negative cubed should go down to the bottom. So that exponent becomes positive. The 2 doesn't need to move. But the x should move down to the bottom, so the exponent becomes positive. The y doesn't need to move. So the only things that need to move are bases that have negative exponents on them. And of course, don't forget, this 2 and this x are not stuck together. They are different bases. The 2 has a 1 exponent on it. The x has a negative exponent. So this is what we have now. We're going to simplify this a little bit more. As you can see, we've got a 3 and a 2 here, and the 2 should be up here to the front with the 3. So we'll have 3 times 2. Then we'll have x to the 5th, y squared, and then the denominator x cubed. I'm just rearranging them alphabetically again, y cubed. And now we can simplify a little bit more. 3 times 2 with the coefficients will give us 6. These x's can reduce. You have 5 x's on the top, the numerator, 3 x's in the denominator. They'll cancel off, but there will be 2 left over, and they will be in the numerator because that's where we had more. With the y's, the same thing. You have 2 on the top and 3 on the bottom. They'll cancel off. There'll be 1 left over, but it will be down here in the denominator. since there were more in the denominator. And that's what we end up with, 6x squared over y. All right, let's look at 16. 2 to the negative third power. All right, negative exponent means the reciprocal. So we need to put this 2 in its reciprocal, and the reciprocal of 2 is 1/2. When we do that, the exponent changes sign. So 1/2 cubed is 1/2 times 1/2 times 1/2, which makes 1/8. It doesn't matter whether you write it like this or with the cube just on the 2, because they come out to be the same thing. When you cube the 1, it's still going to be 1. So it doesn't matter whether you put it on the top on the whole fraction, like this, or just in the denominator of the fraction. When you have a 1 in the numerator, it doesn't matter when you put an exponent on it, it just stays to 1. If it were another number in the numerator, yes, we would need to use it like this. All right, so let's work on putting this -2 exponent on all of these. There's 3 bases in here. So we're going to have a 4 with a -2 exponent on it, an x cubed with a negative square on it, a y to the -4 with a negative square on it. And we're going to use our rules here to simplify those. But first we'll simplify this 4 to the negative square. The negative square means the reciprocal of 4. So the reciprocal of 4 is 1/4. So this is going to be 1/4 squared. Get rid of a little bit of that there. The rule with these exponents is multiply. So this is going to become x to the -6. And again, the rule for this is to multiply. So this is going to become y to the +8. All right, let's keep simplifying here. 1/4 squared, 1 squared is 1, 4 squared is 16, is 1/16. Like this. That's 1/4 squared. This x has a -6 power on it. So it needs to transfer to the denominator so the exponent can become positive. The y doesn't need to go anywhere because it already has a positive exponent. And you don't need this 1 here anymore since we have the y. So this is y to the 8th over 16x to the 6th. Okay, this looks like a fun one. Let's see, we got a lot of bases in here that may or may not simplify, and this exponent on the outside. All right, when we have something big, a big fraction like this, the easiest way to deal with this is to simplify as much as we can inside first before we do anything with this -4 on the outside. So that's how I'm going to approach this. It really doesn't matter what order you do this in because it's all multiply. So you can do it by putting this 4th on here. However, already I'm looking at 12 to the 4th power is going to be a huge number. 4 to the 4th power is also a pretty big number, and then to try and simplify that could take a while. It's easier to simplify this 12 and this 4 first, and then just put the 4th power on a smaller number. So the smaller we can keep the numbers, the easier the simplifying is going to be. So that being said, let's try reducing. 12/4 reduces to 3. It's a whole number 3. I'm going to stretch this fraction bar out because I suspect that I'm going to need the numerator and the denominator. The x to the 5th should probably stay there. It has a positive exponent, yes. The y negative cubed should move to the bottom to become y positive cubed. The z to the -1 move to the bottom, make it z to the +1. All right, we already took care of these, and we took care of these, so let's look across the denominator. We've got an x to the 12. We don't want to move that. It's already got a positive exponent. We've got a y to the 6th, so keep it there. And we've got a z to the -9th, so we should move this one up to the numerator so the exponent can become positive. All right, already it's looking better, a little bit more simple. Let's see, what can we do here? it looks like, oh, we have y's here on the bottom. We can put together, this is y cubed times y to the 6th. So the 3 is not going anywhere. Let's start with x, though. We've got x to the 5th and an x to the 12th. When we simplify those, there's going to be 7 left over. These 5 here in the numerator will cancel off 5 of these, and there'll be 7 left over, and they'll be in the denominator. So we'll have x to the 7th in the denominator. Let's take care of the y's now. Y cubed and y6, this is multiply, so we add the exponents. That gives us y to the 9th in the denominator. The z's will reduce. There are 9 in the numerator and 1 in the denominator, so this one will cancel off one of these, and there'll be 8 left over in the numerator. So we'll have z to the 8th. That looks like it's about it, and we're done. It wasn't as hard as it looked like at first.